Hello, everyone. Welcome back to your channel of basic engineering. We are doing probability this time. And in this session, I am going to use RStudio to solve or to do two things really. To find, um, like to run a test on um, the population variance or to construct a confidence interval for a population variance. But the most important or the second important thing is to show you how to write the solution to an external file. Okay, you save this file and then probably, you know, you submit it to someone or something. So, as we usually do, we will start by clearing the environment, and you will see why I will do that because I'm going to do two problems back to back. And maybe I will use the same variable, so I want to clear it. To begin with, it's not important to clear it because it's already clear, but just to make it a habit, we're always going to say, oops, I'm sorry, remove list equals ls, and that's it. Just that. Now, in the first problem, there is nothing to read because I'm going to give you a very easy problem. I'm going to say, suppose I have a file that has 10 points. I took these 10 points and I was told that it's normally distributed. So, and someone calculated the standard deviation for me. So I know that n was 9. So I'm going to say n equals 9. By the way, sometimes you will see the n is written or the value, especially in computer people, they would write it like that, meaning I'm assigning the value on the right to the variable on the left. Okay, you can write it like that, less than and a dash, or I don't know about Windows, but for Mac, you can click Option and dash or minus. Option and minus simultaneously. Again, it's not a big deal to write two letters or two keys instead of one, but again, if you want to know how it's done. So n equals 9, and then s, the standard deviation for this problem was 2.81. So 2.81. Now I want to construct a confidence interval for sigma square. Okay? So I told you that to find the upper and lower control limit, I'm sorry, I say control for quality control. No, upper and lower confidence limits, we use the Q. The Q gives me the inverse of the function. So if I want the upper, let's call it upper or upper limit or just anything. So I'm going to use U equals, who knows, if I want 95% confidence interval on sigma square, what would be the upper and what would be the lower? Hmm. Q what? Do you know what distribution we use for the variance? For a variance of one population? It's called chi-square, if you remember. We write it like the x square, right? So I'm going to say q chi-square, and once you do it, you see the RStudio will show you the function name as well as what it takes. So it's chi-square. Of course, if it's 5%, I need 2 on the top, so this would be 0.975. And the degrees of freedom, I'm not going to write 8, I'm going to say n minus 1. Likewise, the lower limit would be the q chi-square of 0.025 and n minus 1. Okay? Now, how do I find the actual upper and lower control? So this is just what I'm going to use. But really, if I want to say the upper limit, remember the function? It's n minus 1 s square over the chi-square. So if I want the upper, I divide by the smaller value, which is L. So I'm going to say n minus 1 times s square, right? Because that's the variance. And then I'm going to divide by L. Also, the lower limit, okay, it's going to be n minus 1 times s square over the lower. I'm sorry, the lower limit would be over the upper. Of course, I could have done that in a single line. So I can say the upper limit is n minus 1 s squared divided by the q chi square of 0.025 and n minus 1. And that would be just a single line. But I wanted to break it down to tell you that that's how we calculate the upper chi-square and the lower chi-square for 8 degrees of freedom. And then I I write the upper and lower control limits of that. So now I want to write this. Remember we said cat for like concatenate. So what do you want to say? I want to say the 95%, I'm sorry, 95% confidence interval on S square, oops, S square, um, or instead of that on the population variance equals, and now I want to enter a bracket, lower limit, comma, upper limit, close the bracket. So how do I do that? So I have to the bracket. Oh, I'm sorry. What am I doing? Here is the bracket. And then I want to enter the value. So how do I enter the value? Before that, we learn how to write. We write just LL, right? But now I want it formatted. For example, I want the lower limit to be written in 4 decimal places, maybe because the higher, maybe more than 10, with two uh like four digits with two after the decimal place. So how do we write that? We have a function that would format that for me. It's called sprintf. So it's formatting, uh, it's going to print that, but in a specific format. And this format, we write it between that and with a dollar sign. And then I can enter 4.2, for example, meaning I want 4 digits and two of them after the decimal place. Okay, so I'm going to print something. I didn't say what that thing is. So after that, I would say lower. So now it's going to print the lower confidence interval in 4 digits, two of them after the decimal place. And then I have to add some maybe a space between the upper and lower, right? And then I'm going to write sprintf again, same format, percent 4.2, but this time I'm going to write the upper limit, which we called u. Notice I can click shift and enter, so I continue on the next line. And here I want to close the bracket, right? After entering the L, I close the bracket. And then I can do, I enter the name of the file. I will create a file. Okay, I'm going to create a file. So I'm going to say file equals, and then I'm going to create a new file. So let's call that, I have some data that I stored in a file called example2. So maybe we call that example2 dot text. Okay. And what's important after that is to say that in the first time you create the file, you don't have to say anything. But after that, you have to say append equals true. What does that mean? It means that when I type again in this file, I don't want you to overwrite what I did, right? I want you to go and print on the next line. So in the first time, it doesn't matter, but after that, we have to say append equals true. In the beginning, it doesn't matter, as I said, because I don't have anything written. But so this part, but I have to keep it in mind to keep writing that every time. And then just skip a line. So go to the next line to make sure. Let's see if I did everything correct. I didn't miss. So let's run that and see. No, there is an error. That's what I expected. It says error in sprintf 4.2. Yeah, I said 4.2. I should add the f because I said sprintf, and this would be also uh, yeah, an sprintf. Oh, what happened? Where did the other part go? What did I? Oh, I did that. Okay, so here's an f, and here's another f. Let's see if that. Yeah, so that worked. Okay. And now if I go to my files, I should see a file called example2. So let's do this. Where is example? Here is example2.txt. Yes. Oh, no, I want example2. Oh my God. Oh, instead of I use the same name as, oh my God. So it's my mistake. Okay, so let me delete that and then come here. I'm sorry, guys. I forgot what I called it. So let's call that example2 solution. Okay, dot text. And also, I noticed that we didn't have a comma between the upper limit and lower limit. So here, maybe I'll do a comma like that. Okay, let's run and see. So now I should have a new file. So let's just do that. And here is example2 solution dot text. When I click on it, it says the 95% confidence interval on the population variance is 218. Notice 2 is only single digit, so it leaves a blank, and 2 decimal places, 17.53. In the first line, I could have written, for example, okay, here is the answer to homework number 5, whatever, problem number 1. You can type whatever you want using the cat. There is nothing to format there because there are no numbers. Okay, so let's close this. And now I'm going to start the new problem. The new problem, the data is, so I'm going to copy this line because I don't, if I'm going to use L and LL and N, I don't want to use those. So I'm going to clear that. And then here, I'm going to remember what we said. I'm going to say my file equals read.table because the value is, or the file itself is called example2.txt. Notice this time I didn't open the file. Well, it was opened here because I was checking to see, but let's close it. It will ask me to save it because remember we deleted the last line. So I don't need to open it and then upload it. You see, it's closed. Doesn't matter. I just say, okay, go to the directory where I have all my files. Take the file called example2, open it and assign it to a variable called my file. It's better to say attach my file. So you can access the data attach. No, so there is a missing A. And then make it a habit to detach it after that. So at the end, so I don't forget, I'm going to say detach my file. Okay, and in the middle, I know that example two, they are giving me some values, okay? But there is no header. That's why I didn't say header equals true, okay? They're just a bunch of numbers. They give me a bunch of numbers in a problem and they said, check to see uh, or construct, I think it says upper bound on sigma square on the population variance. So they don't want like a two-sided confidence interval. No, just an upper bound. So I'm going from negative infinity up, of course, from zero, not negative infinity. We know that, but because the variance cannot be negative, but theoretically speaking, from negative infinity up, no, theoretically speaking, it has to, I'm sorry, it's my mistake. Chi-square starts from zero. So from zero up to a specific value. Okay, this would be the confidence interval for that. But before giving me this, they said, we don't know if the data is normally distributed. So can you check that, please, before, because you know, that depends if the data is not normally distributed and the sample size is not large, I cannot neither run the t or the z or the chi-square. All of these depend on normality. So if you run this, okay, if you run these two lines, first of all, it cleared it, and I have 15 observations. Here they are. And I don't have headers, so R, R will call this V1, meaning vector 1. There are 15 data points. So I need to check to see if V1 is really um, normally distributed or not. Some people would say, oh, just plot a histogram. The problem, histogram with 15 data points will not tell me much. So usually we don't use histogram unless we have a large sample. But if we have a large sample, we don't care about normality, right? Because the central limit theorem. So what do? We use something called the QQ norm that checks the quantiles of a normally distributed or normal distribution versus the quantile of your sample and see if they match. So we say QQ norm of V1, and I want to show the QQ line, meaning I want the straight line if I have like perfect normally distributed thing, which will never happen, right? Your sample is not perfectly normal because you are selecting data randomly. So every time you do it, if you are running that as a simulation, every time you will get different values. So what if we run only this line? So control enter. Do you see here you got the normal probability plot? Uh oh, what? Oh, I don't know. I should have done that. That's why I didn't get the line. So let's just rerun it. Run this line again. Oh yeah, you see here now. And you would say, oh, I have points away from the line. Yeah, it's pretty much 1 point, but most of them are close to the line. There is some departure from normality, but generally speaking, they look like increasing linear thing. So the normality assumption is not bad. I can use it. So that's how we check for normality, okay? After we do that, we can do exactly like the previous problem. We are going to calculate an upper bound. It's only upper. So upper bound equals, and I'm going to say, first of all, before doing that, let's calculate how many data points I have by saying n equals the length of V1, and then degrees of freedom equals n minus 1. Um, S square equals variance of V1. That's all what I need, right? Because now my upper bound would equal, well, n minus 1 times s squared, or I could have called it, I didn't want to call it variance because that's uh, a function in, sorry. So times sq, s squared, divided by uh, q chi square. Why it didn't open? Okay. Q chi square of, notice I want an upper bound, so I divide by the lowest chi-square, which is 0.025 and degrees of freedom. Instead of saying n minus 1, I called it degrees. Also, I could have called, oh, that's an upper bound, so it's 0.05. I could have called that alpha, and I could have typed here alpha equals 0.05 and right here alpha, so I don't have numbers, so to speak. And now I can say, I can send this to the file. And before that, I can say, for example, problem 2. Okay, and I do new line. And then I can say cat the upper bound, or the 95% upper bound on the population. I can't type when the thing is so high. Oh my God. Variance is, and again, I open the bracket and say, in fact, I open the bracket and say 0, right? Because I know it's the lowest is 0, and then comma, and then say, um, I can do something else. I can do the formatting slightly different. Um, instead of saying sprintf and then enter that, I can say print ub, right? We call that the upper bound. So it's stored here. And then say digits equals 4. That's another way of doing it. Okay? So instead of writing sprintf, I can say format ub. Oh, I'm sorry. Format ub, digits equal 4, right? There would be another. But then before doing anything, I have to close the brackets and then say file equals example 2 solution, we call that, or example 2 sol. Yeah, sol dot text. And then we say append equals true. And I don't need to add another line because I'm not going to do anything else. Uh, let's close these and run the whole thing and see what other errors I have. Yeah. Where is I don't have a comma here. Let's see what else. Attach my file. Oh, because I call that my file without an underscore. See, a lot of problems. Okay, so now here I have, we already saw that. If you want to print it, you can print it manually so you can go to export and say save as a PDF or save as an image or copy to clipboard. Okay, copy the plot. And then when you go to your file to check what happened, here is the solution. Oh, I thought we did print. Why did it three times? Oh, we did it three times because we ran the file three times. So in the beginning, I think in the beginning you, that's why, okay. Remember when I told you in the first time, you shouldn't say append equals true. Why? Because otherwise, every time you run, it will keep the previous stuff. So let's delete that and run the thing again. And now when I open the file, okay, you see, you get only the solution to the first problem and the solution to the second problem. And you could, um, in fact, I think we said problem number two. We didn't print that. Oh, yes, because I didn't send it to the file. Okay. So I can cut this or copy this, place it here, comma. Now let's open the file. Oh, why it didn't print that? Wait a second. Oh yeah, here it is. The file changed. So it says problem two. Of course, you could have left a space between the first and the second, and so on and so forth. And now you can open this file, you have it as a text file, you can open it and then print in it the the graph that we had to check for normality. But basically what I wanted to show you is that you have now a way of saving your work. You don't have to go every time to RStudio and run the thing and then write down the answer. No, you can send it to a file, and this file you can format it the way you want using, for example, Microsoft Word or PowerPoint or whatever you want. And you have all the data and you can format it the way you wish. Okay, sorry if that was a little too deviated from probability. In fact, we were doing RStudio today, but I hope it was helpful. And again, if you have any questions, please let me know by leaving me a comment in the comment area, and I'll get back to you as soon as possible. Next, we are going to do um, check the variance of two populations, and then probably I'll do also the proportions because we haven't done those. And those depend on the binomial distribution. That's why I really didn't approach them for now, but we can add them to the tests and the confidence intervals of mean and variance. Okay? Thanks for your time and hope to see you soon. Oh my God. Okay, sorry.